Hello guys, so in this video we are here to solve a very interesting problem, and of late this problem is coming in lot of interviews, and out of my own personal experience I've seen that this problem is being asked of late quite a lot. And this problem is find the middle index in the array. Okay, so if you see that this problem is, in this problem we are given find the middle index in the array, and we are given a zero indexed integer array. So the array is integer array and its name is nums. An integer array only contains integers. Okay, and this is asking, you have to find the leftmost index, that is the smallest among all the possible ones. Okay, the leftmost middle index. Then what does it mean by a middle index? A middle index is an index where nums 0 plus nums I and so on till nums of middle index minus 1 double equals nums of middle index plus 1 and so on up till nums of length minus 1. And if middle index is equal to 0, the left side sum is considered 0. Similarly, if middle index is equal to nums dot length minus 1, then the right side sum is considered to be 0. Okay, so this is the problem constraint. Okay, and to solve this problem we need to define, first of all we'll be given an input, and in this input we'll be given, int array nums, and the name of the function is find middle index, and it is going to return the int index because index is always in between 0 to nums dot length, and within that range 0 to nums dot length we have to return the value which is, satisfying the condition of being a middle index. Now how to solve this problem? In order to solve this problem, what we are going to do, that we are going to define one, int n, and this n is equal to nums dot length. Okay, and then with this what we will do, that, see, let's say we are at, index 0. Okay, and it could be that, that 0 index itself is, the middle index. If 0 index itself is the middle index, it means, and this is given in this problem itself, like if middle index is equal to 0, then the left side sum is considered to be 0. So whatever is coming prior to the index 0 is considered to be 0 by definition of this problem. This is considered to be 0, and whatever is coming after the, given array's length minus 1, because the last index is nums dot length minus 1, and whatever is coming after that, that is also 0. Okay, so we need to, keep this in consideration and solve this problem accordingly. So in order to solve this problem, definitely we have to go through each index value. Okay, because we need to find out, okay, which one of them is the, middle index, and what are the range of indexes that are there possible in a given array. It could be possible from 0 to n minus 1. What is n here? N is the length of the array. What n is the size of the, array. How many elements are there in that array? That is n. Okay, now since n is the size of the array, and the index can range from 0 to n minus 1, so all these values 0 to n minus 1 are a candidate for being a middle index, and we have to check each one of them. How to check each one of them? In order to check each one of them, what we are going to do, we'll be initializing left sum is equal to 0, and then we'll also be, putting one check here. If I is greater than 0, okay, if I is greater than 0, see, if I is greater than 0, then only we can go backwards. And how we can go backwards? Int left is equal to the current index minus I, okay, minus 1. Okay, and left should be greater than equal to 0. Okay, and then we have to do minus minus left. Why we have to do minus minus left? Because we want to go traverse towards the left, and minus minus left corresponds to moving ahead in the left direction. okay. And if you are doing it, then we have to do, in this loop, what we'll have to do, left sum plus equal to nums of left, okay, like this, okay. And why we are putting if I is greater than 0? If I is greater than 0, if let's say if I is equal to 0, then what can happen? If I is equal to 0, then left sum is initialized to be with the value 0. If I is equal to 0, then by definition in the problem itself, left sum has been defined to be having a value of 0. So according to the definition of the problem, we are doing the right thing. And now if we go to the right sum, okay, then also we can define the value to be 0, because by default, let's say the extreme case, what is the extreme case here? The index at which we are standing is the last index. What is the last index in an array of size n? The last index in an array of size n is n minus 1, okay. And if you are at n minus 1 index, then beyond that, whatever is the value, that is by definition of the problem, is considered 0. So we are defining right sum is equal to 0, okay. And if in case the current index, if I is less than, if I is less than, not, it's not the last index, if it is less than n minus 1, then in that case, okay, then in that case we can define one int right, okay, is equal to the current I plus 1, okay. If I is less than n minus 1, then we can go one step beyond the current index. If I is n minus 1, then if we cannot go beyond the n minus 1. Why? Because that is the last index. But if I is less than n minus 1, then only we can go beyond the current index. And if we can go beyond the current index, then I can be less than n. Less than n is the boundary, okay. And what we have to do, so sorry, I'm writing I here, it should be a right. And what we can do here, plus plus right. In the case of left, we were doing minus minus left, but in the case of right, we are doing plus plus right, okay. And then what we are doing, right sum plus is equal to nums of, okay, nums of right, okay. And then what we will be doing, if left sum is equal to right sum, okay, then we'll be returning the I value, okay. Otherwise the problem itself tells that you can return -1 if there is no such index, okay. We can return -1 if there is no such index, okay. You can see this here, okay. The problem itself tells that if there is no such index, we can return -1, okay. And so keeping in keeping up with the constraints of the problem, we'll be doing this, okay. And we'll be running this. Now we'll run this solution. Perfect. So it's fulfilling all the cases, okay. So 2 is 0, perfect. Now can we reverse this array, okay. Let's go to this, take this, and we'll reverse this array, okay. So the middle index in this case will be 0th index. Let's check that out. So perfect, middle index is 0 as expected. So this solution is correct. If we submit this solution now, this is running fine, but you see it's running very slowly. It's taking almost 1 milliseconds. Why is that? The reason it is like this, because this is a big O of this solution is big O of n to the power 2. Why it is big O of n to the power 2? Because for every index we are first traversing to the leftmost edge, and for the same index we are also traversing to the rightmost edge. So it means for every index there are n indexes, and for every index we are doing n amount of work, and that's why this algorithm is big of n square. Okay, is there a way that we can solve this problem in big O of n time? Is it possible? It is possible. Let me show you. And I came up with this solution during the interview, and that was, it gave a very positive impact. So let me show that, with you as well. Okay, if int n is equal to nums dot length. Okay, so in this case, we are again starting with the same thing, and then what we are doing, we are defining one int array by the name of prefix sum. Okay, and new int array n plus 2. Okay, so we are taking a prefix sum array, and that array has size n plus 2, where n is the size of the given input array. Okay, and what we are doing here, we are initializing this 0th index with the value of 0, but the first index of the prefix sum, okay, but the first index of the prefix sum is equal to nums of 0. Okay, so and the last index, so if n plus 2 is the size of the array, then last index will be n plus 1, that is also 0. Okay, and now what we will do, we will try to sum all the elements till index I, sum all the elements till index I of array input array nums into the prefix sum. And what we are going to do for that, see, nums prefix sum 1 is already occupied, so we'll start our iteration from I is equal to 2, I is less than. Now you see, prefix sum 0th value is it's extraterrestrial value, it's not something which is coming from the array. The 0th value is 0 because as per the problem conditions, but from 1 we are putting the input array values. So input array values will be going, if it is if we start filling it from index 1, then let's say input array elements are of size n, then the last index will be n minus 1 plus 1, and that is n. If that is n, then it is like this, and then plus plus I. Okay, and then what we will do, prefix sum of I minus 1. Okay, so I minus 1 will be the left side sum, and it should be equal to the right side sum. Right side sum means total, no. So first of all we'll define this. Okay, sorry, prefix sum of I is equal to prefix sum of I is equal to prefix sum of I minus 1 plus array or the input of, so I corresponds to, see, 1 corresponds to the 0, so I will correspond to nums of I minus 1. This we should be clear of. Okay, and after this what we will do, that we will have a a fully populated prefix sum value. Can we check that? Yes. Okay, like this. And then what we will do for int I is equal to 0, I less than equal to n plus plus I, if prefix sum of I minus 1, so it should be 1, it should not be 1, because prefix sum I minus 1 is the left side thing, is equal to, Okay, and we need to find the total sum. So where the total sum value will be located? The total sum will be located in the index prefix sums arrays. The last index is n plus 1, so at the index n the total sum value will be there, and total sum minus, now total sum, and we want only right side value. So total sum is sum of all the elements and we want only right side of the sum index. Then what we need to do? We can definitely reject the prefix sum of the ith index. Okay, like this. Then we'll return I minus 1. Okay, why I minus 1? Because the first index corresponds to the 0th value of the nums array, nums input array. Okay, that's why we have to return I minus 1. Otherwise, if something is not fulfilling this, then we come out of this loop and we can return minus 1. Okay, and if we return minus 1, then this problem is solved. Let's run this. Perfect. Okay, so see here, in this problem the 0th index is 0, then first index is 2, 2 plus 3 5, that is the second index, 2 plus 3 plus minus 1 is equal to 4, and that is the third index. Okay, and now at the third index we have 8, so 4 plus 8 is 12, and that is the fifth index. 0 1 2 3 4. Okay, it's the fourth index, and then here it is the fourth index, and that is 16, and this will be fifth index. So like that, this array is having 5 values and this prefix sum is having 7 values, and with this we'll be able to solve this problem very efficiently. Let me run this solution. Okay, so we can comment this out. Okay, it's not needed while solving this problem. We can just submit it and see it's beating all other solutions. So this is one very efficient solution. I hope you liked it. Okay, if you face something similar, please use this technique and make your life bright and a happy one. With best wishes, I thank one and all. Happy coding.